Morning. Today we're going to find the derivative of this function. We're going to have to use, it's an implicitly defined function, so therefore we're going to use implicit differentiation. We're going to treat y's as functions of x's. So the first thing we're going to do is take the derivative of both sides. We first use the chain rule and we take the derivative of something squared. So that will be 2 times 3x y plus 7. Reduce the power by 1, it's just 1. And then we're going to be times, we use the derivative of the inside. Here we have the product rule, so it's 3 times x. The derivative of the second function y is y prime, plus the derivative of the first function, which is just 3 times the second function, which is y, and then plus the derivative of 7, derivative of the constant is 0, so we won't mess with that. And then the derivative of 6y is just 6y prime. So now I'm going to expand this to a degree. Not going to fully expand it, but I'm going to expand it somewhat. So I'm going to multiply 2 times 3 is 6x times 3xy plus 7 y prime. That's this expression times this expression. And then I'm going to distribute it again here. So 2 times 3 is against 6. And then I'm going to keep that y times 3xy plus 7 equals 6y prime. I notice that I have each one of these terms has a common factor of 6 on both sides of the equals. I have 6 times junk plus 6 times junk equals 6 times, well, y prime. So if I divided 3 by 6, this would actually go away. That makes this a little easier to get. So now I'm going to get my y primes on one side of the equal sign. I'm going to move them to that side because I already have a positive y prime. So I'm going to have y prime minus this expression right here, which is x times 3x y plus 7 times y prime, and that'll leave y times 3xy, oops, didn't write the y, 3xy plus 7 on this side. Now I'm going to factor out a y prime from both these expressions, and that'll leave 1 minus x times 3xy plus 7 on that side. And I'll have still y times 3xy plus 7 on this side. Now I'm going to divide both sides to complete solving for y prime. We'll divide both sides by 1 minus x times 3xy plus 7. And I'll get y times 3xy plus 7 divided by 1 minus x times 3xy plus 7. And I could distribute this y and distribute this x. Why not? We'll just go ahead and do that, just because a lot of books would have put it that way. So we have y prime equals 3x y squared plus 7y divided by 1 minus 3x squared y plus 7x. Either one of these answers is good. I mean, really, if you can get to this point, you've done your work in implicit differentiation.